A5 security misconfiguration are some of the vulnerabilities that in most cases we can fix with, well, vulnerability scans. If we have a misconfigured database, that might not be noticed, but it should at least detect the default passwords, the default usernames, the default settings that a system would come with. It in most cases would also detect if the operating system, the web server, the database management, or any of the applications are not patched and not up to date. And it probably also would detect if we have any features that are enabled that really doesn't need to be. That could be open ports that we don't use. If they don't use them, there's no point in having them open. The same with services, pages, accounts, privileges, all the stuff that when we do our server hardening, we shut off, or at least limit. Those all fall under security misconfiguration. When we talked about vulnerability scans and server hardening, we would normally run a vulnerability scan on a server before we put it into our production environment. We would fix all the issues that we see that are critical enough for us to fix. And then once we have deployed it into our production environment, we would do the same again. And automatically, every so often, the vulnerability scans will run on all the servers, just to make sure that nothing has changed, that no administrator has gone in and taken the easy way out and opened ports that shouldn't be. And to circle back to the first bullet point here, database configured wrong, this can be a mistake, but in most cases, it's an administrator doing something they shouldn't just to make something work. Some years ago, in the US presidential election in 2016, there was a Republican consulting firm that had a database, I think with 197 million registered US voters in a database, and someone went in and turned the security off. Meaning all of a sudden, that huge database was publicly accessible. The AWS server they used for the database was protected by default. Someone went in and shut it off. A6, sensitive data exposure, is, well, our data being exposed. And the most common ways this happens could be that our servers are HTTP, but not HTTPS, meaning they use port 80 and not 443. The traffic is not secure. It could also be that our data at rest, our backups, or our data in transit is not encrypted. With how fast internet connections are now, there really is no reason not to encrypt all our traffic. If you remember, data has 3 states: data in use, data in motion, and data at rest. Data in use, we cannot encrypt. We're actively using it. But either of the other 2 states should always be encrypted. So data in motion, we encrypt the data from point A to point B. Data at rest, when it's stored on our disks or stored on backup tapes, it is encrypted. If not, well, then we're vulnerable. And under A6 is also phishing. We covered those already. Regular phishing, spear phishing, whale phishing, where regular phishing is the one that's sent to 100,000 people, 200,000 people. It is not specific to you or any of your other targets, it's just click here for whatever. Spear phishing is targeted to you or the organization you work for, and whale phishing is targeted on C-level executives. We could also have our sensitive data exposed if we use weak depreciated encryption, meaning types of encryption that we know are no longer secure. This often happens when we have a system in place that has been in place for a while. We know the encryption that we're using there is no longer secure, and we're possibly working on a fix for that or a new system. But instead of fixing the old system, we just kind of leave it there until the new solution is ready, which, well, makes it vulnerable. And then finally, no monitoring if data is being exfiltrated. And many of the large security breaches would have been discovered much earlier on if they had been monitoring how much data and which data was leaving their internal systems. With many of the large breaches, the attackers have been pulling data out for months, because if they keep the volume low, they may not get discovered, which obviously is smart. But if we had had monitoring in place that was monitoring the data being exfiltrated, we may have been able to discover the data breach much sooner. A7, insufficient detection and response, and this is one of the new ones on the 2017 list. And the name really says what it is. We don't detect that we're compromised, or we don't act when we know we are. A lot of the large breaches over the last couple of years, whoever was breached had no clue until stuff started being publicized. And there are a lot of reasons why we do not detect it, and in most cases, it is us not doing something we should have done. Circling back to domain 1, do care and due diligence. Due diligence, we do the research so we can do the job right. Do care, we implement the actual countermeasures. So as IT security professionals, we need to do our due diligence, research how we protect our systems, then we need to do our due care, we need to implement the countermeasures. But it is not just the detection, it is also our response once we're compromised. Because it is not if, it is when we're compromised. What do we do with that information? When we are compromised, we need to inform people. If you remember the Equifax breach, I think it took them 6-7 weeks, something like that, before they actually told the public about the breach. There were thousands of people whose credit was ruined because someone else had opened credit cards with the information they had stolen. Equifax bought the website to protect themselves against lawsuits, and a good deal of the senior executives had sold off the stocks before they plummeted. So obviously, we need to plug the security hole we have so the attack doesn't continue. But then we need to inform people that we were breached and what they should do to protect themselves, what we have done. And then as part of our response, we also fix future problems. What can we do to make sure that this doesn't happen again? Do we need to patch our software, the applications? Are there ports we need to close? The Equifax breach happened because a vulnerability was exploited and the manufacturer of the software had a patch out for 2 or 3 months before the attack. Meaning, had they at any point in those 2-3 months patched their systems, nothing would have happened. OWASP A8, cross-site request forgery, or CSRF, is the attacker tricking the victim into visiting a malicious website or malicious server, where the attacker then forces the user to execute an unwanted action on a web application where they're already authenticated. And this can happen if our passwords or usernames are saved in our cookies, if we do not log off when we're done, or we use the same browser for both sensitive and non-sensitive information. And most of the current browsers can to some extent mitigate this because they use unique session-specific tokens that are either random or pseudo-random, and they validate that the session tokens are not replayed. CSRF attacks are different than cross-site scripting. Cross-site scripting exploits the trust that a user has for a particular site. CSRF exploits the trust that a site has in a user's browser. And because the attack comes from the legitimate user's IP address, it is much more often successful. The example here over on the right, after the phishing attack has been successful, the victim's browser then accesses the bank server. Since they have the username and password saved, and the bank server sees your PC as a trusted device, it doesn't raise any red flags. Since all of that is in order, the bank database will go ahead and transfer the money. And again, reasonably simple fixes. Don't save your username and password. Log out whenever you're done, and don't use the same browser for sensitive and non-sensitive information. A9, using components with known vulnerabilities. And yes, we do this. Obviously, we shouldn't, but we do. That could be our developers using objects or code that we know is depreciated and no longer secure. And they may use the code or the objects because that's what they're used to, that's what they're familiar with, that's what they're comfortable with. Or the library they use for the objects, that's what it's got in it, so they just use it. And then finally, A10, under protected APIs, and this is also a new one in the top 10. And the APIs are the application programming interfaces that is more and more used the more connected we are. And they could be underprotected because they are badly coded. Or we just didn't do enough in-depth reviews and auditing. They might not be using SSL or TLS. And then finally, we could just have forgotten about them. We could have abandoned them. If we no longer use them, we need to remove them, because they still have access to everything they did before. And let's round out OWASP Top 10 with the 2 that left the list in the 2017 version, but I still think you need to know them, both for your job and also for the exam. Insecure Direct Object Reference, is when users can guess a URL or a file path that they shouldn't, but they can because it is logical. So if, for instance, we have a PDF that's called financials_May 2017, and I should have access to that, if I wanted to see June or July's, it would be a safe bet to guess that probably that PDF is going to be called financials_June 2017.pdf. I have many times guessed URLs, found information that technically probably shouldn't be publicly available, but since they put it on their website and they didn't do anything to protect it, I'm okay to access it. And the fix here again is simple. We have proper access control on our files and our web pages, we use non-sequential and non-logical names, and we monitor the file usage. And then lastly, unvalidated redirects and forwards. In most of the places I have worked, whenever we add a new website or a new solution, we just kind of put it on top of the old one and point things in new places. And if something is critical enough and we get enough complaints, then we probably just do a redirect, which is also a really bad idea. When we migrate to a new system or a new website, one of the things we need to do is train our users. This is the old URL, this is the new URL. And we can also automate it and use a spider to crawl our site and see if it generates any redirects. They would normally be HTTP response codes somewhere between 300 and 307. Most commonly 302. Once we found that, then we can fix it. And on the exam, I don't think you're going to see what is OWASP A3. You're not going to see questions like that. What you might see is they might describe a scenario, and the scenario is, for instance, a CSRF attack. Then you need to identify this is what's happening. So I would know the entire top 10 plus the 2 that left the list in the last update and understand how each attack works. Let's move on.